All right. Good morning, everyone. And looks like Robert is joining us now. Are you there, Robert? Looks like his audio is still connecting.
Hey, can you guys hear me now?
Yes. Good morning. How are you?
Sorry about that. I got lovely bandwidth connection. I was trying to connect with my phone, but for some reason that wasn't working either. I apologize, guys.
Oh, no problem.
I'm in my very glamorous COVID studio here called my basement.
Yeah. Looks pretty fancy.
Well, I've got the funny joke about this is that my wife is an interior designer, so I got relegated to the basement. Every other part of our house is fantastic except for this part.
Nice. Well, thank you very much for joining us this morning. Really appreciate it.
Sure, my pleasure.
So good morning, everyone. This morning we are being joined by Robert Rock, who is a principal at Living Habitats, the firm that's very much centered on ideas of environmental sustainability and creating landscapes that are harmonious between humans and natural systems. And he previously was with Michael Van Valkenburg Associates, was the team lead for their competition-winning Ark Wildlife Bridge in Vail Pass. And today he's going to be talking about that project and some of the other work that he's been doing that relates pretty closely to some of the theories and some of the principles that you guys have been learning about for landscape ecology. So without further ado, I'll turn it over to Robert.
All right. Well, thanks, Scott. I'm actually going to stop my video so I don't screw up my bandwidth while I'm trying to share stuff on the screen with you guys here, and then I'll jump back to that once we get to kind of a Q&A. Let me jump over here to my other screen. Give me a second. All right, can you guys see the screen?
It's coming up. There we go. Yep.
All right, so you guys should be able to see the, oh, wait, hang on a second. You guys are seeing the Zoom screen.
Nope, we're seeing the lecture slide.
Okay, you're seeing the high power nature slide. Okay, something screwed with my Zoom here. It's got the controls on the wrong side. All right, well, as long as you guys can see the slides here, that's the important part. So what I've got two different PDFs that I'm pulling up here, mostly because I meant to put these two things together, but I was caught up in a lovely call with a client about money just before this, which ran over. And it's always a pleasant conversation, having conversations about money with clients. So apologize, these would have been compiled into one to be a bit more seamless. But what I was hoping to do is I wanted to share with you guys this project from my time at MVVA and how this is kind of parlayed into the work we're doing on the wildlife crossing at Liberty Canyon out north of LA. This competition dates back to 2010, and whether I'm assuming you guys have seen some of this kind of stuff or you're aware of this project based on the context and coursework that you guys are working on. But essentially what this is an international competition that was organized by a group called ARC Solutions, Animal Road Crossing, or the A, the R, and the C as part of that. And what this was meant to do is it was meant to look at a collaborative team approach for how to bridge infrastructure networks with these kinds of pieces of habitat connectivity. And what that really meant for the competition organizers, it was taking these things out of the realm of conventional kind of DOT type structure and pushing this a bit more into the design realm so that we would get past this inertia of effectively retrofitting things like railway crossings and technologies that were completely and totally overwrought for what they were meant for, and were not really specifically targeted at connectivity so much as they were targeted at reducing roadkill. And so the task of the competition was to create teams that blended the skills of landscape architects, engineers, and ecologists. And so this project was a combination of us working with Ted Zoli and his group at HNTB, as well as uh, Applied Ecological Services, who we were kind of working with as our ecologist at the time on this competition. Ultimately, this project didn't come to pass. It was mostly because I believe it was 2011, when you guys had those kind of catastrophic floods that you guys had in Colorado. All of the budgets and the funding for this project kind of got swallowed up by that effort. When Hickenlooper was very much a supporter of the idea of the project, but when all of that stuff happened, obviously priorities had to be reset. So ultimately, this project didn't actually come to fruition as we were hoping, but it was initially something more than just an ideas project. So the intent here at Westvale Pass was to kind of create this stitch across the road, reconnect the landscapes on either side, and find a novel way of doing that with the structure. And so I'm sure you guys have seen some of these components that are part of this, but really what we started to think about is how do we create something that's modular and mobile and adaptive. So each of the units for the structure themselves were based on this kind of hyperbolic paraboloid shape that you see here on this diagram and on the structural efficiency side of this diagram, and how to create these out of these kind of straight board forms. So this came from in an engineering world, they in the same way that we as landscape architects build on other practitioners' work and kind of find ways to take pieces of it and build and take things in different directions or enhance and evolve things. The same thing happens in the structural world. So this was a combination of kind of the DNA of an engineer named Felix Candela, and some work that was done by him that really involved using straight board forms and less skilled laborers to create these kind of thin shell concrete structures that were able to be done in a fairly streamlined fashion, kind of a low tech strategy. And then also blending that with the ability to accommodate the potential impacts from an environmental standpoint, and the fact that this was created as this 3-hinged arch, so that if there were ever a landslide or there were any sort of sag to the grade or an avalanche or something like that, the structure had the ability to absorb that kind of move. So the structure was built of these units. They were all stacked together across the midpoint. And then each of these were highway transportable in the fact that they were a size that you could put on a flatbed trailer and transport to pretty much any site as a precast concrete element. So this was kind of an erection sequence. And then this was the diagram kind of showing how the soil and the kind of geosynthetic reinforced earth strategies would be used as that part of the counterweight to balance the structure. So the way that we approached this in the competition, we tried to make as big of a structure as we could within the budget constraints of what they were targeting. And one of the things about the efficiency of the unit was that it allowed the cost to be much more effective. And so we were able to, instead of creating something that was about 50 meters wide, which is kind of the target based on the competition, we were able to create something that was about twice that with the same amount of budget. So this is effectively, not down to the foot, but effectively, if you look at this is about the size of a football field, inclusive of both end zones. So the funny thing about that is that as I'm going to show you with these other slides about Liberty Canyon, we effectively have taken something along the lines of this module and turned it the other direction to span across the 101 north of LA in terms of the shape and the scale. So there is some parallel and some analogous relationship there. But at the same time, this diagram and some of the other ones that were part of the competition talked about how ecological principles could be used to kind of start to cultivate the complexity necessary in an environment like this, where we were trying to rebuild the ecological value and stitch it back into these long fragmented habitats on either side. And using these kinds of principles for thinning and for controlled burns as a way of starting to build some of that stuff back into the overall strategy. So you know, this is the image, the rendering that kind of gets propped up a lot of the time and gets used as an example of the competition. But really what this was doing was, you know, trying to create a piece of continuity, creating this kind of banded approach across the structure. And I think we've learned a lot about how these projects work since this competition. It's kind of unfortunate this one didn't happen at Westvale Pass, but it really served as a kind of an incredible springboard into this project that we're working on right now, which is the wildlife crossing at Liberty Canyon. So I don't know if you guys have seen this rendered view that's kind of been out there. This is part of a press release that went out in October of last year and has kind of been blasted across different airwaves as a part of it. But are you guys seeing the rendering of the mountain lion here? Did it switch in time? Okay. All right. So what I'm going to focus on as I go through this, I want to focus on the kind of the thought, the collaboration, and everything that's kind of gone into this project, and what that's really. I'm sorry, hang on one second here. I got something glitchy happening. Give me 1 second. Let me flip my screen stuff around here. Technical difficulties.
Yeah. Fun in the Zoom era.
Exactly. All right, I'm gonna do full screen. Let's see if I get that to work. Okay. You guys still seeing just the full rendering?
Yep.
All right. For some reason, it was like spanning across, showing two different screens here. All right. Let's just make sure it keeps going. So this project we came into this project after there was a lot of inertia that had already begun, and it's interesting because it's this unique collaboration between these 5 very small groups. You got Caltrans, which you know, obviously is a juggernaut in and of itself, but this would be District 7 where we're at because it's just north of LA near Agora Hills, kind of between Agora Hills and Calabasas. The Santa Monica Mountains Conservancy, the National Park Service, the Local Resource Conservation District, and then the National Wildlife Federation. The project is, I mean, it's built on 20 years of research performed by scientists at the National Park Service who've been studying this challenge for the bulk of their careers. And you know, they're incredibly dedicated, incredibly gifted individuals. But essentially what they were able to uncover is that without this piece of connective infrastructure, without this crossing, kind of bridging the space between the Santa Monica Mountains and the Simi Hills, the California mountain lion would effectively be extinct within the next 50 years. And that's because it's because of reduction in home ranges. And those reduction in home ranges motivate things like inbreeding and competition between males of the species, things of that nature. And so what we've actually come to find out, just because of the longer timeline in the history of this project and this initiative, is that over the course of the last year, they were able to, they've actually started to see some of these signs of degradation of the species in the kind of monitoring and the tracking that they've been doing with litters of kittens in the last year, where one of them literally had a kinked tail. Like, we're talking about something on the order of a Pokemon. Like, it looked like Pikachu or something. Tail was kinked all the way to the right, like a 90-degree turn to it. And another one that was only had one testicle, right? So you're starting to see the results of the inbreeding as a part of the, you know, the impact to this overall population. But one of the projects that, or one of the reasons that the project has become so incredibly dynamic and so resonant is that when NWF, when the National Wildlife Federation came on board, and the woman who's in this photo here, her name is Beth Pratt. She's the California representative for the National Wildlife Federation. When they came on board and they kind of took a hold of this as a champion, they created a whole litany of different things to kind of press through as a champion for the project. You know, and a lot of this is based around the story of P22, which is the mountain lion that you see here in the photo at the bottom, and the cardboard cutout propped up against Julia Butters there in the image above. But the California mountain lions as they make their way between different areas in the LA area or in the LA region, are challenged by big pieces of infrastructure. The 101 and the 405 are just massive interstates that wrap all the way through this space, and they separate and they bisect different areas. P22 was able to make this kind of 50-mile trek across two of those on his way into Griffith Park. And Griffith Park, for those of you who are not familiar with LA, is the location of the Hollywood sign. It's the observatory. It's kind of like the backdrop for all of Hollywood. And it's not a very large park. It's much smaller than what P22's home range would have been. But he's coexisted in that space for quite some time now and has become the poster child for this project. And so they created a whole series of narratives around this, right? They've got P22 Day, where they talk about coexistence with urban wildlife. They've got the Save LA Cougars website, where they have a whole bunch of tchotchke that they sell too, about, P22 is my homeboy, things like that. The whole series of different narratives intertwined in this. But ultimately, the reason that I'm bringing this up is that it is part and parcel with how these types of projects become important, become kind of monumental, and get to a scale where they're actually able to be achieved. Because if you didn't have this sort of support network behind a project like this, a lot of people might just dismiss it as, why are we creating a piece of infrastructure that's not geared towards humans, right? Because it's misinterpreted, it's misunderstood. But on a global scale, or sorry, I shouldn't use the word global. On a nationwide scale, the impact of wildlife vehicle collisions, it's anywhere between 1 and 2 million collisions that occur each year. And that accounts for almost $9 billion of impact to the economy. So the idea that we've got this type of issue that we're not really strategically solving with crossings as a tool for doing that seems kind of silly when you think about the numbers involved. So anyway, I'll get off that piece of the soapbox for a moment. I'll start kind of dive into the project here. So this is the urban jungle of LA, right? So you got concrete jungle down here, and kind of as you get further north and you kind of make your way out on the 101, it starts to look much more open here. Here's Calabasas, here's Agora Hills, and the crossing is effectively here where this green arrow's at. And for those of you that are keeping up with the Kardashians, the Kardashians are here in Calabasas, so this is kind of in their backyard. You can imagine the lovely jokes about catwalks and things like that from the fashion industry, and how that ties back to a cat as the feature animal for the crossing, right? Love how my jokes on Zoom kind of fall flat and deadpan. So apologize.
Welcome to my world. It's impossible to actively inject humor on Zoom.
Yeah, it's unfortunately my entire existence is kind of revolves around humor and sarcasm. So this Zoom living is killing me here.
Yeah.
So as we zoom in a little bit closer on the site, you see that the 101 really starts to bisect this area. So you've got the Simi Hills here to the north, you've got the Santa Monica's to the south, and we really only have this location here where the two things connect, where the two spaces that are publicly held land connect. And this is literally the last stretch along here where there's a piece of kind of connective thread of publicly held land on either side. We've got 1,600 feet that we've got for being able to bridge across this here. And aside from the fact that we've got that kind of narrow space, we're bridging across one of it's either depending on which calculation you look at, it's either the second or the third busiest location within the U.S. Infrastructure system, at over 300,000 vehicles per day passing this site. So pretty substantial. And then on top of that, we've got a fun 125 foot of grade change that we're accommodating here as well. So lots of fun variables. But what you can see here from the existing site plan, you can see the Ventura Freeway. We also have a second less talked about crossing, which is the one across Agora Hills. And then, to make, this whole thing, if those challenges weren't enough, we also are trying to come and touch back down before we come up against all these large heritage oaks and this little unnamed creek that's a tributary to Liberty Canyon Creek that kind of drains its way back down through Malibu here to the south. So we've, as things evolve over time, like, the roadway network changes, it streamlines, we flatten it out, we speed it up. So, we went through, and one of the ways we look at projects like this, we kind of dig into the history of it, dig into the DNA, the kind of core essence of it, and evaluating how things evolve over time. And if we are looking to create some sort of ecological stitch here in this kind of reconnection, how do we do that? How do we inform ourselves based on the history? One of the interesting pieces of this, so we can start with, and this is another former MBVA here standing in the distance. This is Rich Hindle. He's
Rich Hindle. Rich was a student of mine when I taught at RISD.
Oh, perfect.
Yeah.
Yeah, so Rich and I actually worked together on the ASLA Green Roof before he left MVVA and moved on to teaching at UC Berkeley. But he's a part of our team for this, and very much a part of the conversation about contextuality of this crossing within the landscape, the history, the kind of the ethos of what we're trying to do. So you can start to see some of the challenges here. We also have these lovely utility lines we got to deal with. But ultimately, these renderings like this are always fun for us to do. But how do I want to talk about how we got here, right? So this location in the Santa Monica Mountains in this kind of general vicinity is one of 36 biodiversity hotspots worldwide, and it's a result of a series of qualifying factors, right? It's not just animal species, but it's also threatened flora species as well. So this project, as much as this is geared towards this initiative of P22 and the kind of him being the kind of banner animal for this initiative, this is really about restitching an ecosystem across this roadway and reinforcing the biodiversity of the site, and creating a continuity of habitat across. There are other crossings that you might see as examples. There's one that's up at a location that's finally referred to as Slaughter Row up in Utah. That's essentially just gravel ballast and a bunch of stones across a piece of concrete, and it works fine there. There's nothing wrong with those types of solutions, but they're trying to create a crossing. It's targeted at specific species, and they're really just talking about trying to mitigate for the kind of roadkill. And there's also less sensitive species that they're accommodating in that type of project as opposed to what we're trying to accommodate here. So we're trying to stitch this back across the road and create this kind of connective thread that's not just about the mountain lion or a handful of species, but rather an entire suite of species, both flora and fauna. So this is a kind of a random smattering of some of the target species that are a part of this. And we're literally looking at things all the way down to, it's kind of silly to put a harvester ant at the same kind of scale and representation as a mountain lion or a bobcat on a diagram like this, but we really are looking at the complete system. And that takes an incredible amount of collaboration. So this is just a kind of a light touch lift of the different people who are a part of our team, either within our Living Habitats team and extended network or within Caltrans. Because the way we're working on this, we really are kind of working hand in glove with Caltrans District 7 to advance the final engineering drawings and get this built. So how do we start with things like this? How do we look at this? Well, one of the things we did is we took and we unpackaged their PSR phase, their kind of preliminary site report phase, where they were literally just looking at things like site distances on the roadway and, how does it stitch back in? What's the first kind of architectural gesture that's there? We took this and then we started to pull us apart into the different design parameters, and we established this series of kind of icons. They're meant to be kind of light touch and kind of and very graphically inclined, so that they're easy and accessible, and they're the things that kind of create this connective thread all the way through the project as we start to talk about each of these facets with the different functional units at Caltrans or with our own team. And we broke them apart into different groupings, whether it's wildlife characteristics or landscape performance or placemaking and disturbance mitigation. So I picked a couple of these things just so I'm not going into each of those different facets, so I can kind of focus on these, and then we can get to more of a discussion, because that's more fun in my mind anyway. So we'll start with something easy, with vegetation, right? So we started with vegetation, and as sexy as a drawing like this or an image like this looks, how much we all love Excel, right? it's very good for soliciting input from our collaborators, specifically those that have been a part of these types of projects for a long time, or are the kind of scientists that kind of categorize things and keep things in this type of format as part of the reporting that they do, or the record keeping that they're doing. But it's, you know, as much as this is interesting and there's a lot of content here, one of the challenges we face, and probably one of the core values that we have as landscape architects, is our ability to be, our ability as generalists to be able to understand and interpret a lot of content, but not have to be the expert at any of it. So we take a spreadsheet like this, where we've got everything from, you know, which plant community are these individual plants a part of, to what is it serving in terms of the type of habitat, to things like the accumulated temperature, because, you know, we obviously are dealing with wildfire because it's California, right? Or, you know, just ecological value and the perspective of ecological value viewed through the lens of a land manager, as someone at MRCA, one of the project partners, as well as a biologist at Caltrans, and then also folding in biologists from our own team. So we're using this as a way of kind of stratifying the list, figuring out what species we're going to work with, and really leveraging the experience of the people who have had their boots on the ground, who live there, who are of this place, because we aren't, right? We're coming from Chicago, working in LA. It's a Mediterranean climate, completely different set of plants, completely different suite of environmental reactions that we have to deal with. But then we start to suss these things out, right? We start to look at, you know, what are the variables that exist within this vegetative palette, whether it's aspect ratio and elevation, or it's all the way down to the plant community, the habitat, or the soil characteristics that they're paired with. And we start to then extrapolate a bit further. Why are we looking at this set of a dozen trees? Why are we looking at this 24 set of shrubs? And how does this factor back into everything from, you know, their electrical conductivity, which is a variable as it relates to soil and the kind of relationship between plant and soil and root structure? Or how does this serve the pollinator and beneficial insect community? And then at the same time, you know, if we're looking at climate change, we're looking at adaptation, what are the species that are going to be able to kind of buffer the most across the changes we're going to see? How does that relate to the accumulated temperature, which is like the rate at which something is going to burn, and relates to how this factors into things like growing seasons, because the growing season's entirely different there too in this climate. And how do we accommodate for all these variables while understanding that things like fire are a part of this landscape? Taking this over into the soil side of the category, right? So this is a report from our mycologist who's out on site, taking these samples, root samples, soil samples, evaluating, I'm not expecting anybody's looking at this and really understanding all the different variables, because I mean, to some extent, I don't understand all these different variables all that well. I understand excellent, low, good, as qualifiers and quality, but the number of our arbuscular mycorrhizal fungal spores within a 10 gram sample versus 1 gram sample, like, why does that matter to me? I don't really know, but I do know that it matters relative to what we're trying to do, which is reconstruct a soil profile that is something that's going to have the sort of reciprocity, the potential for nutrient cycling within the plant community. And so what we're doing here is then we're trying to distill this information down to its core elements, present it in such a way that our collaborators who are wondering why we're spending so much time geeking out about soil, why does this matter? So, we take, these types of diagrams where we're looking at everything from, the generic description of soil profile, but then we're trying to create a graphic representation to explain this to our collaborators, or explaining what the hell we're talking about when we're talking about mycorrhizal fungi, and why, right? Why do we care that there are different types of mycorrhizal fungi? Why do we care that there's a relationship between these elements? And how do we show that? How do we create a graphic representation of, a chart, a report from a mycologist, to make this tangible and accessible to the people that we're working with, and explaining to them that, look, as we start to reinstitute these plants on the site, we need to have all these variables in play and understand how those all go together. But I'm going to go one step beyond that level of geeky to the next level of geeky here, which is that we get even down into these conversations about geomorphology and geology and why that matters. And in some locations, it may not be quite as important as others, but the unique thing about this site, because we are in this very active seismic region, this tectonic region, we have this dichotomy between sedimentary stone, sedimentary rock on one side of the freeway, and igneous rock on the other. Two completely different types, right? So we got metamorphic on one, igneous on the other. And what does that mean? Well, it means that we have to understand how that informs the soil, how it has evolved over time, how it has built up and created the profile that's there. If we're going to mimic and recreate something tying back to the natural condition, and getting super geeky about things like oxidation and reduction, or hydrolysis and leaching, or how thermal expansion creates difference in pore space, and how that lends itself to the kind of core elements of the soil profile. So now I'm going to jump into something that's totally unique to this type of project, which is the impact of sound and light. I'm not going to spend too much time on the light so much as the sound, just in the interest of time here. But when and this is a fairly new term, calling things soundscape ecology. Everybody likes to slap the word ecology on the end of some other term to give it some sort of categorization. And really what this means is that there's a combination of different sound elements that exist within a given natural landscape. Some of them are impacts created by humans. Some of them are sounds generated in natural processes. So understanding the collection of sound, whether it's the biophony, which is the sound of living organisms, or it's anthrophony, which is human produced sound, is important for how we need to identify what we need to buffer and where. And again, like this is one of those unique challenges. Like, how am I talking to the structural engineer who really just cares about getting a slab of concrete to fit over top of this road and protect the travelway, about why sound is a piece of this equation? Right? How do I create something that explains why we have to do something a little bit different than just putting up a sound wall? So one of these presentations required a conversation where I literally extracted some of Caltrans standards and compared it to a series of white papers, and explained in a very kind of concise and clear way that most sound mitigation as it relates to traffic corridors is geared towards the kind of human recognition of that sound, right? So we put up a sound wall along a development, and essentially when you see that sound wall, it has an implied impact and value to you because you see it as something that's buffering sound, and that has a distinct impact to what you perceive as sound, depending on what wavelength it is. But reductions on the order of 5 to 10 decibels are considered substantive enough to warrant the erection of that sound wall. But that's not necessarily a huge reduction in sound as it relates to some of the more sensitive species. So how can we do better than that? So we started to talk about, these are things that are straight out of the Federal Highways Manual, right? Everything about line of sight, reflective sound, absorptive sound, diffusion, refraction. And the challenge here is that we have one, as I said previously, one of the busiest roadways in the entirety of the US, right? If you create a concrete shell over the road, and then you create concrete walls that mirror either side of that road, you're creating this giant concrete box for sound to bounce around in. And for anybody who's ever meddled with their car stereo, you realize that the way that your sound system works in your car, if you don't have the kinds of things to absorb sound and the things that bounce off of sound, you end up having this kind of cacophony of nuisance, right? Because the sound is constantly bouncing off other things, right? So if you think about acoustics, even if, let's say you go to a concert at some concert hall, you've got acoustic elements with things drop from the ceiling to bounce sound in different ways or absorb sound in different ways. Well, on the highway environment, what we would be creating if we didn't do something to buffer for the sound values that we're seeing, which are on the order of anywhere between 70 and 80 decibels, we would be creating what's called canyon effect, with the sound bouncing off all these surfaces and eventually spilling out at the ends. So we tried to explain that why we're trying to create this vegetated barrier. There's a litany of other reasons that I could get to, but if we're just talking about it purely as sound, we're trying to change the reflection angle of the sound. We're trying to absorb more of it because density of that unit that you're using to mitigate for sound is a factor in how much it can absorb. And then we're adding vegetation to further diffuse the sound as it bounces off. So then, and again, I like using the word geeky because I fully embrace the fact that I'm a complete nerd, but we're going beyond the standpoint of it just being sound volume or sound decibel level to the point where we're talking about the frequency, right? Because conventional sound barriers are good at attenuating high and medium frequency sounds. but low frequency sounds are the ones that are going to be the most impactful for the smaller species within our target range that exist within that soil profile, that exist within that habitat, that aren't just the people who are using it or the species that are using it as conduit, they're using it as habitat. So how can we mitigate for, how can we plan for those low frequency sounds, and trying to explain why that matters. If you look at the difference between a low frequency and a high frequency sound, it's a difference in the length of that sine wave, right? And so if you think about sound generation on the left-hand side of this and the receptor on the right-hand side of this, the distance that sound wave travels in that time frame, if you're trying to mitigate for one cycle, this is much longer than this single cycle from a higher frequency pitch here, right? So we need to accommodate that buffer for that low frequency. So we're trying to create more density for that sound in terms of how it travels through. So this is one of the ways we were trying to explain that, is that as you think about low frequency sound and the impact to the environment that's at that ground level. So if you imagine this area where I've got the low frequency label shown being the space we're trying to protect, the thickest part of that value is going to be buffering for that low frequency sound at the lower part of that profile, because you're creating more space between the source and the receptor to attenuate more of that sine wave as it travels through. So, all these conversations around sound and how these kind of tie back, this is some diagrams where we're working with our acoustic engineer to figure out how to add other value. Can we create other baffles within the soil volume where we don't need as much of the soil volume there to support the plants? How can we expand that and enrich that profile? And then finally, wildlife, right? So this is why we did this to begin with anyway, right? In the beginning and circling back to wildlife. We've got incredible biologists that are part of our team, plus the ones that I referenced from the National Park Service that have been working on this for the bulk of their career. Again, in the same way that we're working with the biologists, looking at plant communities that I referenced at the beginning of this, we've got the same kind of incredibly appealing spreadsheet. I swear, I think if there's one program that I absolutely despise that we work with, it's definitely Excel, mostly because I just don't understand how those damn formulas work in there, and like the fact that things don't round to 2 decimal points. I mean, come on. I don't understand why that's necessary, but anyway, I'm getting a little bit off topic. So we got these species. We understand, whether or not their habitat is close to the crossing or not. We understand, what type of habitat we're suiting for, what types of soil they might exist in, if they burrow or not. And again, all of this stuff is, aside from my own, love of the chart, explaining this to a general populace is really difficult. So how can we distill this down? How can we make this substantive and tangible and accessible for folks, and show them, from this chart, we get, target species, their lifespan, their weight, why that matters relative to their home range, right? And showing the relative home range difference. You've got, a bat, which you think flies everywhere, but their home range is only 2 to 4 kilometers, as their home range, versus a mountain lion, which is 100 times that, right? So taking that, then you kind of branch that into the next piece of what's in that spreadsheet, right? This is the relationship of how these animals move, what type of day they're moving and why they're moving. Is it because of mating or nesting or hibernating? And how does that factor back into us creating a design solution? Same thing here. Their food, their habitat, their shelter, like what do they eat? Who eats them? What plant community do they exist within typically? And then, again, taking it, now we're taking that information from the kind of sequence that I'm showing here. So from spreadsheet to that series of diagrams back to something like this, we're taking accumulated knowledge from wildlife biologists. We're distilling that down, representing that in a broad brushstrokes kind of way to the rest of the team, to the rest of the collaborators, to the general constituents. And then we're coming back again to the wildlife biologists to understand the difference between open, closed, and edge habitats. And then how do we take something like this, where we're talking about the difference between open and closed being the difference between it being 30% woody shrub and 60% woody shrub. How do we then translate that back into construction documents that we're doing with a whole bunch of engineers at Caltrans in a format that's entirely unique to Caltrans, and ultimately getting to something like this. So I'm gonna end on that slide. I mean, these were a couple of a couple of the other graphics that were part of the press release back in October. But one of the things that's important to acknowledge and to realize about work that we do like this. I mean, this stuff does not happen without incredible collaboration with others. And on top of that, I mean, there's a lot of nuance, there's a lot of data, there's a lot of depth to all of these things that we study, but we always have to come back to how can we make this accessible? How can we make this make sense? How do we make this tangible for folks so that they care about it the same way that we do? And that's something that I feel like we spend a lot of time thinking about. How do we present this information in a way that's substantive and meaningful? But at the same time, it's not just a sprinkling of ecology on top of a finished design. It's not some gloss that you just kind of say you've got some sort of ecological underpinning, but how do we build from the science, from the data, and still come to a final end result that's something that's beautiful and functional and performative, and ultimately has a level of resonance and meaning for folks.
So, Robert, we had a question from Emma, who is asking whether there's any difference for a wildlife crossing that goes over the roadway as opposed to one that goes under the roadway in terms of noise and sound mitigation.
Sure. No, it's a great question. The difference between the difference between the two. I mean, from a sound standpoint, and this, our sound engineer would kill me for making this as the reference, because he doesn't like to dial things down and to their brass tacks. But sound, in essence, if you think about sound traveling like water travels, it emanates from that point, and if you don't have something to stop it or redirect it, it's going to continue to flow through. And so the challenge with sound generation as it relates to over or under crossing is that the sound source along the roadway is effectively from the wheel well of the car. It's not the exhaust. The exhaust is a contributing factor, but where that sound is mostly coming from is the friction of tire to pavement, how that echoes within the wheel well of the vehicle and then emanates out from there. So that 3 to 4 foot of elevation off the roadway and sound coming out from there, if you imagine that sound comes out and then drops down to where an undercrossing is at, if there's not something to kind of mitigate for that, you end up having a lot more sound spill and bounce over into those lower areas than what you would have if you have it elevated above, where you're able to try to control a bit more of that getting to the elevated surface. And it's not a hard or fast rule in that regard. But the other thing that factors in here is between over and under crossings, there are some species that will use one but not the other. And so in general, what they found through the kind of years and years of research on this topic is that over crossings tend to accommodate a much greater diversity of species, especially when you're able to scale a structure to a certain size. And there are guidelines that are part of this that have been developed through mostly a lot of the work that Western Transportation Institute has done at Montana State University, that give these kind of variables of kind of between 50 to 100 meters as being the effective width of a crossing to most graciously accommodate impacts from sound, from light, and from the kind of traffic corridor. So that was a very long answer. I apologize.
Oh, that's great. So yeah, we had looked at there was one precedent that we had looked at where it was relating to the Florida panther and some of the work being down there in that conservation effort. And in that case, there was a proposed canal that never got built in Florida, and the roadway was elevated way high above the landscape to allow for that canal that was never built. And that one seemed to be a pretty effective passageway. But again, I think it's because the roadway was so high above the ground, which is not the typical condition that you find if you're trying to do an underpass.
True. It's also because, and this is the case with the mountain lion too. Mountain lion or the panther, they're part of the same family. Mm-hmm. And they're not quite as particular. Like they have coexisted within the kind of human fringes for so long. Plus they're as a predator species, less challenged to have those types of impacts than say a prey species might be. right? A prey species is looking for cover. It's looking for the ability to navigate, in a nocturnal setting, or being able to navigate with things like echolocation, like bats do, where impacts from sound or light do things to disrupt everything from their circadian rhythm to their, their foraging or foraging habits, or their mating rituals. So when you're talking about something like the Florida panther, which again, I've had some conversations over the years with folks like Nina Marie Lister, who I know has been down there and has been a part of that conversation with what's happening with the Florida panther. And the work that they're doing down there has a parallel to these mountain lions in California, and the fact that there's genetic diversity issues that are occurring down there. But again, it's oftentimes these types of conversations about what's most effective and how they get ensconced in the local DOTs, or the state DOTs, or the kind of local organizations. And, there's a bit of territorialism that comes along with that, because of just the folks that you're talking about and that you're dealing with, whether it's the folks who've been researching them locally, or it's the DOT with thou shall not do this, that, or whatever, because it's not in their standards.
Mm-hmm.
You're kind of dealing with some of that too. So sometimes when these types of projects come up, part of what ARC Solutions has morphed into since that competition in 2010 has been to become this pool of resources, so that when these questions come up, they can serve hopefully as a conduit to help inform and infuse that process, and help those entities when they're kind of struggling with the questions that are often, on competing sides of the argument.
Mm-hmm. And I was also wondering if you could talk a little bit more about the thinking behind that sort of striped arrangement of plants that was in the ARC competition that you guys did. I assume that's to accommodate a variety of different types of species.
Yeah, it is. And it's interesting because sometimes you do things in competitions to win the competition. Mm-hmm. And other times when it comes to a real project, you do things that are baked with a bit more nuance based on location. And in the competition, the reason we took that approach was there was something meaningful about talking about how what we're doing is we're resetting the system, right? We're resetting into a space that had long been fragmented by that, by I-70, right? And I-70 is a huge, that was a huge project when that was done, during the Eisenhower age, right? When that was cut through all the portions of the roadway that are elevated, that wrap around the edges of the mountain. Mm-hmm. It's one of the most gorgeous pieces of infrastructure that I think I've ever driven in my life. The challenge, though, is that when those areas have been so removed from the connection that they once had, a lot of what you've got to do is kind of start with something that you're going to have to design a process for how it's going to be managed and how it's going to morph over time and allow for that sort of ecological process to rebound. So the idea with the banding that was there is that in some respects, it's similar to what I was showing with Liberty Canyon Project with the kind of open, closed, and edge habitat. There are some species that want to have an entirely covered and closed thicket to navigate through because it's their kind of defense against predation. There are other ones that want a much more open experience that they can kind of see. They have that kind of sight line, right, in that corridor to travel through. So in some respects, the response from the competition was one where we were acknowledging the ecological principle of those open, closed, or edge type habitats in a way that was understandable as a narrative. But I can imagine that if we would have continued forward with that project, that would have evolved into something that's much more similar to what we're doing with Liberty Canyon, where we're talking about the kind of the critical mass of how much open or closed you really would have, and working within the framework of those types of elements, the open and the closed and the edge that exists along the rift between the two.
Great. So I actually do have a couple of other questions, but I want to open it up to the students and see if any of the students have questions for you.
Well, before anybody asks, I have not met the Kardashians, nor have I met Kanye.
That's what I was going to ask. So
okay, took the words right out of your mouth.
Oh no. I was actually just wondering, so when you get those giant Excel sheets,
Mhm.
how do you take that information and synthesize it to something that like makes sense to you and you can make sense to other people?
Sure, sure. No, that's a great question. So in some respects, it's based on what your audience is going to be, right? So if it's a very specific conversation, say with let's say it's a conversation with the structural engineers about how we're going to protect the slab, right? I know that I've got to have a conversation with them about how saturated the soil is going to be and how the root system is going to interact with the structural elements of the bridge, right? So I may go to that plant chart and see that, okay, this is a plant species that needs, really saturated soils. It needs water constantly, and its root system has a tendency to go to 5 foot of depth, right? I know that that's one where it's maybe not suited for on top of the structure, but it may be something that exists in the deeper soil as we approach the abutments, right? So I might suss that information out, talk about that plant community, and explain that, okay, we're looking at this suite of plants because the root system does this, the water values are this, it's going to need this amount of irrigation, so we're not going to put it on the structure, we're going to put it in the adjacent kind of approach landscape, right? So there's some of it that's that, but I think the other piece of it is that when you're, what's the best way to explain this? So if you're baking a cake, you've got all the different ingredients that are part of that cake. Or hell, if you're going to make cereal in the morning and you eat cereal like a normal person, as opposed to my brother-in-law who eats it with butter on his Cheerios, which, don't get me started, it's ridiculous. But if you got ingredients that are part of whatever it is you're creating, you know what the important pieces are. You know that, from that to make that cake, you got your flour, you got your sugar, you've got your water, you've got your eggs, and eventually you got your frosting, right? But when you look at that recipe and you look at all the content that's there, you got to figure out how you create that cake, and you're reverse engineering this cake, realizing you've got to create that recipe and then explain to someone the instructions for how to put it together. To some extent, that's what we're doing by taking that chart. We're figuring out which pieces are going to matter for the components that we've got to translate through to people, and then finding ways to lump them together or parse them out in a way that's that's more accessible than someone looking at that Excel spreadsheet.
Great, thank you.
Sure.
So Eduardo posted a question in the chat. He was asking what the greatest challenges are in terms of creating greenways or wildlife corridors along in urbanized areas, as opposed to bridging over infrastructure like the Arc Wildlife.
Sure. No, it's a great question. I think the biggest challenge is, and not to get all state specific with all you folks from Colorado there, but there's a different appreciation for wildlife based on location that you're at, right? And so there's a different understanding of how that wildlife exists in the construct of how you exist and how you move through space. So a lot of the challenge relates to what that messaging is and how you respond to the critical evaluation of what it is that's being done, right? So taking the mountain lions as an example, I mean, that's not, I'm sure you guys have seen, like, there was a video probably what was it, like November, December kind of time frame of the hiker that encountered the mountain lion that started to chase him, right? Mm-hmm. Well, if you listen to what was out there and what they shared in those news stories, they talked about him doing the right thing, not turning around, making noises, throwing something, eventually getting the cat to go away. If you talk to the wildlife biologist about what occurred, that was entirely because it was a female and her kittens were probably somewhere near, because the timeline relative to gestation period and the animals in timeline of where they would have been at, he probably was someplace between her and her kittens when the encounter occurred. And when he backed up far enough, he got past it so that she eventually ran away when he startled her. All of that is well and good, but those types of stories kind of conflate things. The issue here is that there's plenty of conversation and narrative around the California mountain lion as it relates to the urban core and what that means in that part of California, because it's a species that has gotten a lot of exposure, whether it's through the P22 narrative or it's the conversations about coexistence that occur within that entire, within that entire region. So a lot of it's about the education, a lot of it's about the communication of the coexistence piece of it. And it's something that, I think we generally, in a more universal sense, we lack a lot of that coexistence conversation. Like a lot of there's a lot of education that can happen on that front, but I think as you get to the urban core, that conversation becomes entirely different from the landscape of Colorado, where you're in the mountains and you anticipate coming into contact at some point with, a bear or, or a lynx or a coyote or whatever it may be, right? The context in the urban core is a little bit different, but as long as there's a good established narrative and you have the ability to respond to those questions, you can eventually make progress. You're never going to suit everybody. I mean, it's the whole thing of NIMBYism, but just tilted to the animal scale as opposed to crappy architecture.
So would you say with these types of projects that the biggest hurdles are, is it money? Is it politics? Is it existing design standards? Is it all three? I mean, if we had a Bill Gates type come along who just wanted to throw their entire fortune at building wildlife crossings, would that be a feasible solution, or would there still be, just a lot of pushback against it?
So Scott, when you win the Powerball and you decide that's what you're going to dedicate all that money to,
Yes.
And let's have a conversation. It's in most respects, the challenge is on the kind of political side of the spectrum, or the kind of standards and standardization side of the spectrum. That's usually where the biggest hurdle is at. Because you can always find groups that want to do something. You can always find someone who creates some level of inertia around a project like that. But oftentimes the challenge is one where, you don't have the correct land holdings on either side of the road to allow it to occur. And so some sort of legislation's got to take place where you either have to expand the DOT's right of way to allow something to happen within the DOT's right of way, which means that you're going to have then a conversation with whoever the landholder is adjacent, and you have, the challenging dialogues that go along with that. Or you have a situation where you don't have an established standard for how you tackle that given challenge, and because, and this isn't a knock on Caltrans or any other DOT for that matter. I mean, you've got a series of standards and protocols and practices. You've got the forms that you have to check the boxes on. You have a very linear process that you have to follow, because that's how those entities function and how they exist. So in some respects, that ends up becoming a significant challenge. And it's one of the things that, I made reference to ARC Solutions as being the competition organizer that's kind of morphed since then. That's one of the things that they've pushed back heavily on, is trying to help change those standards, how to help change those reference points so that clears that hurdle out of the way, because these crossings don't have to be as expensive as, it's not like these things are layered in with golden flake or something. The reason that the crossing at Liberty Canyon is as costly as it is that it's a Herculean feat. I mean, we're spanning across 200 feet of one of the busiest roadways in the entirety of the US. And then I was being kind of cheeky with my comment about, 125 foot of grade change and utilities. And I mean, burying high power utility lines on the order of 66 kV, which is like a primary supply line for an entire metropolitan area, that's not a small feat to bury a utility line like that, right? So funding is always going to be a challenge, but it's not an insurmountable challenge, and it depends on location. You can do these crossings much cheaper in other locations. It just so happens that this location has got some incredible variables at one of the last possible locations where we can relink the Simi Hills and the Santa Monica Mountains.
And then the last question I have is, how do you, once you plan and build one of these crossings, how do you tell the wildlife where it is, right? Because you have, you might have a roadway that's got tens or dozens or hundreds of miles of barrier, and then you have this one crossing in a place. Do you just build it and wait for them to find it? Are there other changes you can make in the larger landscape that kind of gives them clues about, do you have to put up fencing along the entire rest of the highway?
I mean, it really helps if you have a giant neon sign and kind of cookies on a table across the crossing. You know, just cater them to wildlife, and you'll be good. No, again, sarcasm. My penchant for sarcasm coming through. No, I mean, a lot of this is look. You can't do these types of projects without having the expertise of the wildlife biologists. Right? They understand how wildlife are going to move. They understand which target species we're working with. They understand the variables that go along with that. And to some extent, you don't plan a crossing location if you don't understand that the animals you're targeting are going to tend towards that piece of connective tissue you're going to create. So it's planned. So it starts there. It starts with the right location for the crossing. It's not simple enough as
it's not a build it and they will come kind of thing.
But no, I mean, to some extent it is. But I think the thing I wanted to point out is that when you're looking for that location, it's not a matter of like, where's the most roadkill, and so let's put a crossing there. It's understanding that, in the, for Liberty Canyon, it's the fact that you've got the mountain and you've got the draws, right, coming down the slope, and you've got the stream corridor, and knowing that the species that we're targeting travel along those routes, knowing that that's where they're going to tend. And if we're creating a crossing someplace, we need to make sure we create a piece of connective landscape that ties back to that, to promote that connection, to provide that resource, and to design back in the things that we know they're going to use as those kinds of, metaphorical breadcrumbs. But in any regard, it's still a little bit of build it and see if they come. Right. That's why we do pre and post monitoring with these types of projects too, is to understand how effective they are and what things may need to be tweaked or adjusted. But the other part of this that's absolutely critical to wildlife crossings is making sure that you've got the types of fencing structures or the other types of physical elements that serve as that funnel, right? So we have fencing that's going to extend out from each of these four corners, and we're trying to create dual purpose by using these gabion wall structures and these earthen barriers to create slopes that are not traversable for certain species, right? Or we're trying to use those surfaces as pollinator habitat as a way of giving them additional value along with getting grade up and over the road. I mean, there are ways to be creative within that envelope, but ultimately, if you're creating something like this, you have to create the funnel along with it.
Great.
Looks like there's another question in the chat here.
Oh, I beat someone to the Emma had a question. Oh yeah, about the funding.
Okay.
So forth. Yeah. Okay. Anybody else have any other questions for Robert?
I have one more.
Sure.
So when you're designing these areas or the crossings in fire-prone areas, is there any type of like preparation you do for that if you're worried about like fire crossing the road, or like, are you trying to promote it?
So yeah, I mean, anytime you design in a fire-prone region, you have to factor that into how you design. And there are, CAL FIRE has their standards, they have their restrictions, their requirements about safe zones and buffer areas and things like that. But you also have to understand that it's an ingredient within that landscape that's not going to go away no matter how much you buffer for it. So to some extent, you're also trying to acknowledge those variables in the same way that we have to plan for and adapt for climate change. You have to adapt for the possibility of these different things that are going to impact you, regardless of if you put 1,000, fire extinguishers around the perimeter that you can go out there and press with a single key, right, when the fire approaches. The crazy thing about this location is that because of the slopes and the relationship on either side, this area was well, let me back up one second. So this area was incredibly impacted by the Woolsey fire. That Woolsey fire ripped through thousands and thousands of acres. And when it came to this specific location, it didn't just jump the road, and a conduit like this across the road isn't the thing that's going to make it spread. Because especially in the California landscape where you have elevation and Santa Ana winds to deal with, the fire jumped the freeway because embers blew across the freeway.
Mhm.
Like it wasn't that the fire got so big that it just, licked all surfaces and jumped across the road. It's because the windblown embers got across that roadway. So you're not going to get rid of that. But part of what we, and I didn't have this in the presentation, but one of the other things that we did is we looked at fire ecology and how do you plan for the fire prone landscape. You're not going to plant your this is going to be my one and only dig at MVVA in a lighthearted way, but you're not going to do a Michael landscape with plants slammed up against one another in this kind of adapted natural environment, because you can't, right? You can't have plants like that are that close. You can't have understory trees planted next to large canopy trees, because that, in combination with the slope ratio, that fire just is it's going to ramp right up through that, right? So you have a different planting aesthetic that you would use in this type of location than what you would use, as a conventional landscape approach elsewhere. And so there's that, and then along with it, understanding that fire ecology in and of itself is not just about the fire and its impact on the plants, but also how that changes the soil strata, right? It's going to change depending on the intensity of the fire. It's going to change how that crust of the soil, once that fire is done, is going to become different. Is if it's a high intensity fire versus a low intensity fire, the surface of that soil is either going to be completely devoid of nutrients for a certain depth, or it's going to have a kind of a glassiness to it that's going to promote more water sheeting off of it and eventually result in more landslides, right? Or, um, challenges with infiltration. There are all those different pieces that are part of it, but as long as you can plan for the right plants that respond to that fire environment and have a strategy for how to come back into that space to help to tend it after the fire, like all of those things are part of how you have to think in that type of environment.
Yeah, absolutely.
And a question from Emma, does the vegetation on the crossing require maintenance afterwards indefinitely, or does it just become sort of naturalized and self-sustaining over time?
So that's a great question. It's a little bit nuanced, but I'll try not to go too far over the top. So the unique thing about creating spaces like this is that you're always, whether this is just kind of a general trend within the industry, or it's specific to these types of projects that are more ecological restoration based, there's a general perhaps misconception that you can just plant with native plants and just kind of set it and forget it. And I was going to make a Ron Popeil reference that no one on this call, except from Scott, probably would understand what the hell I'm talking about. But Ron Popeil was like the guy who used to do infomercials before all the guy who's got the flex tape and stuff like that. And he used to like set these appliances up and then forget it. You like go and do your thing and come back to it, and your food is done for the next day or whatever. Like you can't think of landscape that way, right? You can't set it and forget it. There's always there's always a stewardship component of any landscape that you're trying to restore or that you're trying to maintain, right? It's the nature of the beast. And beyond that, because we are working over top of structure as well as areas that are on top of grade, we've got a diversity there too, right? We've got this postage stamp of kind of green roof on steroids, right? And then we've got landscape on either approach built on top of soil. So one of the interesting challenges for someone like the irrigation consultant is, how do I make sure that that postage stamp on top of structure, that, green roof on steroids, is going to be the same across the entire year worth of growth time as those two sloped approaches? And it's going to be a matter of monitoring, soil moisture content in both of those locations. It's going to be specific to open or closed habitat and the variables between those two things. It's going to be understanding how much water is coming off of the surface of that soil on the deck and going back in the landscape versus how are we accepting that drainage through the profile, pulling it out and reusing it someplace else in the landscape. So there are a lot of technical variables that go along with that. But in all respects, it's not just about making sure that you're tending to those plants. You're tending to that entire system. You're tending to the soil, you're tending to the water inputs, you're tending to the vegetation as it changes and evolves over time. And then, dealing with, what Caltrans cares the most about, which is that structure needing to be maintained as well.
Mhm.
So great question, Emma.
Great. All right, we're just about at time. Does anybody have like any last things for Scott? Sorry, for Robert. I'm sorry. You can ask me questions anytime. All right. Well, thank you so much, Robert. I think that was really fascinating. I think it's kind of an amazing aspect of landscape architectural work to be engaged in. And I just know from my own experience, like these big multidisciplinary projects are where you really just learn so much about all these other things that impact what we do that you don't always necessarily think about on a typical project. So thank you so much for sharing that experience. And
Oh, my pleasure.
for this.
Oh, my pleasure. Yeah, and please tell Jane I said hello, and
Will do.
tell Streeb that his his lovely magazine spread for his family in their local magazine was lovely.
Oh, I did not see this. Wait, what magazine was that?
Oh, I don't know. It's like one of the local real estate type magazine things.
Oh, okay.
He and Danilda and the kids are featured in it. It's pretty fantastic.
Oh, I gotta look that up.
Yes, very very glamorous.
Yeah, very nice. Great. Well, thanks again, and have a great weekend. And for the students, the recording of this will be posted on Canvas. And yeah, that's it for today. So thanks again.
Bye, everybody.
Thank you, Robert.
Robert.
Everyone.
Thank you.
Thanks.